Hello everybody. Today I am going to explain a very interesting conceptual example for 19. Even though there are no apparently any kind of calculation, but if you understand how to create the free body diagram for these two situations, where here the person is pushing his little sister on the sled and here he's pulling her, all right? And the question is asking really if we are pushing or pulling with the same angle. So angle is fixed here. This is theta and this is the same theta. But with which situation, pushing or pulling, will require the person to apply more force to move the little girl on the sled. So the question is to push or to pull. Basically, we want to use the less force. Of course, we are always trying to reduce the force which is used for our own comfort, to push or to pull. Now, the important thing here to be able to create the free body diagram for both situations. So here, this is an object, okay? And we will consider it as this is the center of mass of that situation. We don't care, basically, for the shape. You know, we are dealing with anything as a particle. And definitely, this is the object. So there will be mg, or the force, the gravitational force on this object, which is, you know, this is the pushing situation, this is the pulling situation. If you see in both situations, mg will not change because this is kind of constant. It depends only on the mass of the object. So mg is the same. If you see direction is downward, the size of the vector is the same in both situations. And that's it. Everything else will be different. If you are pushing something, if you remember the object, the example where there's an object and the person here, he leans with a force, you know, I think it was example 4.7 or 4.8, I don't recall. It's the box which was at rest on the surface and the person he pushed, you know, over it. What happened to the normal force? Does it increase or decrease? If you push, basically you are applying more force on the surface. So that definitely you are applying more. So definitely the reaction of the surface will be quite bigger than normal mg. Yani, again, if you remember when there was only an object on the surface, fg used to be equal to fn. So we will draw them same size, but of course with different directions. So this is mg or fg, and this is fn, and it's at rest, so they are equal to each other. But when we apply with an external force as a reaction, the surface will push further. So there will be fn bigger, larger than the normal force. And this what happened. It's still, of course, perpendicular upward, but now it is relatively bigger or larger, basically, than the gravitational force. All right? While, so I am just comparing both situations. So Fn here is more than Fg. What about if you are pulling the sled? If you are pulling the sled, now get back to the example where this is the object and we start pulling. When we are pulling, it means we are reducing the stress on the surface. So the normal force from the surface, the reaction will be less. It will be less. So it will be less than mg. So if this is the normal situation where Fg and Mg are Fg and Fn are equal to each other, if we are pulling up, the result will be that Fn will become smaller, or if this is Fg, Fn will be smaller than Mg, because now you are here we have applied force. You are pulling up, so there will be less stress on the surface, so Fn becomes smaller than Mg. This is a very potential multiple choice question. It could come from very different, angles. And it shows that without numbers, how can we create a free body diagram? Okay? Now, recall one more thing. What is the friction force? Or here he's writing F friction. Regardless, it is mu K times Fn. This is just a simple constant, but it is proportional to the normal force. So if normal force was big, there is the friction force, for example. When normal force is smaller, the friction force will be also smaller, and they are very, we can compare them with each other. If I will ask you, the friction force will be more or less than a normal force, usually this value is smaller than 1. So if you multiply anything with something smaller, which is a fraction, this definitely will be a smaller number, but not much smaller. It will be comparable with the Fn. So if you see the size of the arrow, it is smaller than Fn, but not with much big difference. Okay? And definitely, since the motion is to this direction, so F friction will be to the opposite side of the motion. While here, when the normal force was smaller, so as a result, friction force will be smaller. Yani, I could bring you this kind of problem, and I will, maybe draw everything, and I will, for example, leave Fn and friction force missing, and I will say complete the following graph, and here it's pushing, here it's pulling. So you will come to know in the pushing, basically you are applying more force down. And you can also understand this from that there will be a component for this F down, right? While here, the component will be up. So that will help to pull the object upward, which will reduce the normal force, which is the reaction of the surface. And friction force is proportional to Fn. So if this becomes smaller, this definitely becomes smaller. But you can see very clearly that there is any difference on the Mg in this situation. So in which situation we need less force? To push or to pull? It is to pull. Pulling, you will need less force basically to move the sled. You will need less force. Again, why? We have discussed the Mg and the Fn situation. If friction is more, you will require more force to move the sled. If friction is less, you need less force to move it. Since this is the situation, the pulling situation is with the less friction, it means the person require less force to overcome the friction and to move the sled. I hope, guys, that I make this example clear to you. Try to compare it with what was happening here, okay, in the pulling and the pushing situation of the box, and how the normal force was really getting affected, that if you are pushing down, it means you are putting more stress on the surface, so Fn will become bigger. It will become bigger. And while if we are pulling up, you are reducing the stress, so the reaction will become smaller. And then you are discussing the friction. Friction is proportional to Fn. So if N is bigger, then friction force is bigger. If Fn is smaller, then friction force is smaller. Now, which force, or in which situation we are requiring less force? With the less friction situation. So definitely it's the pulling situation. All right? Thank you, guys.